Welcome back. We continue. I think I had these done up to, for example, part C. So I hope you guys were able to do the next one, B. I've shown here. So we see here secant function and the tangent function, and then we have this cosine function here. So as I mentioned, if you see a mixture of these secant, cotangent, cosecant, and then you see a sine or a cosine in the same problem, then better convert everything into cosine and sine. That's what I did. Secant of t will be 1 over cosine of t. So the minus cosine of t, because that is, we keep it as it is, then divided by sine of t divided by cosine of t. So now that this is a complex fraction, if you notice, this is a complex fraction. How do I solve it? There are several ways, two ways mainly, and you must have seen. You will note here that the common denominator of the numerator you can do so that is cosine of t, because there is 1 under here. So I have the common denominator as cosine of t. So on the top I get 1 minus cosine squared t, and then the bottom it remains as it is. Now at this stage there are two ways to go with this. One way is which I wrote here, and the other way is from here. You can go like 1 minus cosine square t, remember, is sine square t, so we will come to that in a minute. But before that, notice that the common denominator of the numerator is cosine t, and the common denominator in the denominator is also cosine t. So this denominator and this are same. So what we can do is multiply the fraction by top and bottom by cosine of t. In other words, I multiply here by cosine of t, and I multiply the bottom by cosine of t. Then cosine t cancels, and we are left with 1 minus cosine square t over sine t. But 1 minus cosine square t is sine squared. So remember I mentioned that we should know the other forms of the Pythagorean identities. So we have then form sine squared t plus cosine square t is equal to 1. So from here I can write subtract cosine square t on both sides. So we get sine square t is equal to 1 minus cosine square t. So also we should be able to see that cosine square t is 1 minus sine square t. So these as needed, you can get the form from here that you need. There is actually another way to do this problem as well, which I will show you after we do the next next two which are here. So because these simplifications can be done, some of them can be done in more than one ways. So here we have tangent t over secant of negative t. Now remember secant is 1 over cosine t. So cosine t was a even function. What does that mean? That means cosine of negative t will be equal to cosine of t. If cosine is even, then secant is even. So secant of t will also be, secant of negative t will be secant of t. So that's what we can do, or we can convert the secant into cosine. So that's what I did here. Note here, first I wrote it like this, although I didn't need to, I could directly go from this step to that step, but just for your understanding. So remember, if you have a over b, you can always write it equal to a times 1 over b, or you can write it as 1 over b times a. So however you want to write it. That's what I did. So tangent t over secant of negative t, I wrote tangent of t into 1 over secant of negative t. Now 1 over secant of negative t is cosine of negative t, and the tangent is sine t over cosine t. Again, applying the even identity, cosine of negative t is cosine t. So we have cosine and cosine cut cancel here. We are left with sine t. So let me show you another way to do this problem. So what we could have done is, instead of changing the secant into 1 over cosine and tangent, because we are now changing two parts of or two expressions in our given expression. So how about if we take this secant of t minus cosine of t over tangent of t. So above I showed you that cosine t is all equal to 1 over secant t. Cosine is the reciprocal of secant. So we can do that. Secant of t minus 1 over secant of t over tangent of t. Then we have secant t into secant, so we take the common denominator in the numerator, which is secant of t, and then rewrite it. So I'm going to take a common denominator in the numerator, which is secant t, and then I can get secant square t minus 1 over secant of t divided by tangent of t. Now when we try to simplify, now this becomes secant square t minus 1. But what is secant square t minus 1? Again, if you recall, the first Pythagorean identity is cosine square t plus sine square t is equal to 1. Divide by cosine square t, you get 1 plus tangent square t equals secant square t. If I subtract secant negative 1, we get secant square t will minus 1 will be equal to tangent square t. So here we are getting tangent square t divided by secant t whole divided by tangent t. So if you simplify, this becomes secant of t times tangent of t in the denominator. So 1 tangent t goes away, so we are left with 1 tangent t on the top. But now, in order to simplify, we have to convert it to sine and cosine. So the tangent is sine of t over cosine t, and the 1 over secant will be cosine of t. So again, cosine cancel out, and so there both methods are almost of the same difficulty or same work, same amount of work. So whichever is easier. I believe this one, the first method, is slightly easier because sine cosine are more used more often. Next one. So it's sine of t over cosecant of t. So remember, cosecant of t is 1 over sine t. So or we could have thought of it like this, that sine of t times 1 over cosecant t plus cosine of t into 1 over cosine of t. Sorry, 1 over secant of t. But 1 over cosecant t is sine t, so we get sine square t. Or if you want, I can write it like this, plus cosine of t into cosine of t, which gives us sine square t plus cosine square t is equal to 1. So this is how you can simplify these identities. Okay. So next topic is verifying these trigonometric identities. So just listen carefully how we do this and what are we. Okay. The major concept in this section is to be able to use these simplification techniques that we just learned. We want to now verify trigonometric identities. Verify means we are checking or we are proving that this is true. Now these identities, as I said earlier, these are not equations, so we don't deal with them like equations. When we have equations, we can multiply both sides by something or subtract something from both sides. Here we cannot. Although there is an equal to sign and it looks like an equation, but these are not equations. So how do we verify these identities? So for example, we have to verify this identity, which means we have to show that this side and this side are same. So the expression on the left of the equality sign is called the left hand side. So this is the left hand side. We denote it by LHS. And the expression on the right is the RHS, right hand side. So if one side is simpler than other, we start with the complex side and simplify it to match to the other side. So for example, in this one, you can see that the left hand side is complicated. Right hand side is very, very simple. We cannot do anything basically to right hand side. We cannot simplify it further. So we will start with the left hand side and we will try to show that this is gives us what we are seeing on the right hand side. So we start with the complete. We will see later in the problem that sometimes right hand side will be more complicated and the left hand side will be simple. In other cases, both sides might be complicated. In that case, we will start working with one side and try to simplify it as much as we can. If the simplified result of the left hand side is not the same as the right hand side, then we will work with right hand side and try to simplify it and get a result which gives us the same simplified version which we have on the left hand side. So here I have shown the solution. The left hand side, I wrote the left hand side. If you don't want to write it, you can jump to this step. So then I saw in the expression sine and cosine and then tangent and cotangent. So first instinct is convert the tangent and cotangent into sine and cosine. So that's what I did, sine of v over cosine of v plus cosine of v over sine of v. Then I saw the two fractions being added, so did the common denominator, and then the top becomes sine square v plus cosine square v, which by the Pythagorean identity is 1. So I'm left with 1 over cosine v sine v, and then multiplied by sine v cosine v, and you can see that they cancel out. So we are left with 1, which is equal to the right hand side, and that's what we wanted to prove or show. Another way of doing this one is that once we have converted the left hand side into the sine over sine v over cosine v plus cosine v over sine v multiplied by sine v cosine v. So we can distribute. So we get sine v over cosine v times sine v cosine v plus cosine v over sine v times sine v cosine v. So here cosine v cancels, and here we get sine v and sine v get cancelled. So we are left with sine square v plus cosine square v, which we know is equal to 1, is equal to right hand side. So we are done. So note again here, these are not equations. We cannot move things from one side to the other side because we are not solving anything here. Rather, we are basically simplifying. And simplification will require the use of identities, factoring, common denominator, multiplying by the conjugate, etc. All the things that we do in algebra. And clearing fractions is not a way to simplify. So remember, if we are solving an equation, for example, if you have x plus 1 over x minus 2 plus 3 over x equals 1, how do we solve this equation? We try to clear the denominator. We try to multiply both sides by the common denominator so that we can get rid of the denominator or clear the denominator. Here we are not doing that in this solving the identity. So let us look at the first one. So here the first is verify example 2, verify each identity given below. The first one is tangent of theta over secant of theta equals sine theta. Actually, we have had this in the previous problem that we did in simplification, but this now we have to show that the left hand side is equal to right hand side. So you can start with the left hand side. Tan theta over secant theta. So we can write this tangent as sine over cosine, sine theta over cosine theta, and the 1 over secant theta, or you can write it as this whole thing divided by 1 over cosine theta. So it becomes sine theta over cosine theta multiplied by cosine theta over 1. Cosine and cosine get cancelled, so we are left with sine theta, which is equal to the right hand side. And that's what we wanted to prove. Looking at the next one, again, the left hand side looks complicated, so we will start here. If needed, we can write this as what? Well, there are several ways to think about it. So let's first look at what the left hand side is. So left hand side, which is sine squared theta plus cosine squared theta plus tangent squared theta. Good. So now if you recall, this gives us 1. So we get 1 plus tangent squared theta. But now what is 1 plus tangent squared theta? This is equal to, if you remember, the sine, the Pythagorean, all three identities in the Pythagorean identities. One of the identities is 1 plus tangent square theta is equal to secant square theta, which is what we are getting, so it is equal to right hand side. Now if you cannot see that, then you can do it, I should say, or maybe do it with another color, or left hand side is equal to sine square theta plus cosine square theta plus sine square theta over cosine square theta. Now at this stage, if you cannot see that this is going to give you 1 and you try to take a common denominator with all these three terms, it will become very complicated. It will become more complicated. So instead of simplifying, we'll make it more complicated. See, this is kind of something that should come immediately. That when you see sine square theta plus cosine square theta, it is 1. So we are now can write it 1 plus sine square theta over cosine square theta. So now you can take the common denominator. So it means there is 1 here. Common denominator is cosine square theta. So on the top we get cosine square theta plus sine square theta. The top is 1, which is so this is another way of doing this. Okay, the next one. So we have left hand side. Again, we see on the right hand side there is only 1 term, whereas on the left hand side we have a fraction minus an expression. We can always put a 1 under here, and so we have a difference of fraction. Whenever you have difference of fraction, what comes to mind? That you should try to take the common denominator. So left hand side, we'll start with the left hand side and try to simplify that. The left hand side, which is sine of alpha over 1 minus cosine of alpha minus cotangent of alpha. So I'm going to change it to cosine and sine. So cosine alpha over sine alpha. So now you should be able to see that the common denominator is 1 minus cosine alpha into sine alpha. So the numerator will become sine of square alpha minus, so remember we have cosine alpha times 1 minus cosine alpha. So expand. Okay. So we get this. Now note here again, we can rewrite this expression as sine square alpha plus cosine square alpha minus cosine alpha whole divided by 1 minus cosine alpha times sine alpha. Now what is the top? Well, again, the sine square alpha plus cosine square alpha is 1. So 1 minus cosine alpha, and the denominator is 1 minus cosine alpha. Like in the case of algebra, do not multiply out the denominator. We did multiply or distribute in the numerator. We saw that. We did that here. Distribution. But we do not do the distribution here, okay? So we do not distribute or multiply the denominator. We keep it in factored form. So we have now 1 minus cosine alpha times sine alpha. So now we notice that the 1 minus cosine alpha and 1 minus cosine alpha, these two factors cancel out. We are left with 1 over sine alpha. Now if you cannot or did not realize that 1 minus sine alpha is cosecant alpha, you can leave it here, and then you can work with the right hand side. So say right hand side is equal to cosecant alpha, but that is equal to 1 over sine alpha, which is the same as, then we say okay, we leave it here, and then say this implies left hand side equals right hand side, and we are done. I will let you guys try the next one, and then we will see how did it work. Oh, by the way, for the next one actually, so what we will do, as you can see, there are two inequalities. So what I want you to do is show that this is the same as this. Later on, we will show the second one is the same as the third one. So that is will come. So I want you to show this first, the first one, that the left hand side. This is left hand side, and this is the right hand side. So first you are going to work with secant x. Well, first we are working with this identity. So you will forget this one for now. Just work with these two, and I'll see you. I'll be back within the new video.